All right, so before we jump into the meeting, let's look at this month's Python pop quiz brought to you by Mike Driscoll. Now this one is a little bit more intensive than some of the past ones, so we're gonna have to do this one in Visual Studio Code as opposed to a REPL. I suppose I could do a REPL, but it gets a little tricky if we're gonna be changing imports or functions, what have you. Now we've had some suggestions here. Robert had an interesting one talking about undefining the function, deleting at some point, and then also had some.
I mean, yeah, the obvious answer is you just use best practices and you don't override the name of the module, right? That's the obvious answer. But the more interesting answer is there a way that you could if it say in a Jupyter session, if you polluted your namespace by creating this bonehead function name, could you get rid of it?
Right, right. So I guess we can look at all of them real quick. We get a lot of 101 Python 101 types around here. So one of the things you can do in Python when you're importing a library or module is you can give it something of an alias. So you do
Where did the F come from in line 7?
so that is an F string that's formatting values based on these like curly brace things. So we have a value that's being passed into number here when that function main is called. And so in the case of number, 8 is being substituted for this value of number. And then so in F strings you can do function calls and whatever is returned there, as long as it's printable, can be dumped in. There may be some special rules there. That a handful? I don't know. I feel like Deanne might know off the hand. Can you dump an
It
object
helps
in
with
there?
string interpolation, right? The F format string.
Yeah. There's some other ways to do it. But yeah, F string was released. What was that? 3 point something, 8. I don't know. But did that
2.6.
0.6? Okay.
Yeah. You
3 points.
in modern Python, you end up typing that F for the F string so many times you don't even realize you're doing it.
Yeah, exactly. All right. So one solution was to not do the proper thing and instead overwrite the name of the module, because the issue here, oh wait, I'm sorry. Let's back up and let's run this thing. So we get an error here. Attribute error, function object has no attribute square root. So I think we all know that if you're in Python, square root of 9 or something like that, that would give you 3, right? So obviously math, which we imported, has a function called square root. So what happened here? Well, look, going through here, we've defined 2 functions and we called one of them math. Now that's a problem, right? Now we've got a module that we're hoping brings a bunch of tools to the table, and then we're creating a function. So we're basically overriding the math module with some dumb function called math that takes a single parameter and returns what we hope is the square root of that. But unfortunately, we've overridden. So what did we end up with here? If we had a function inside that was called square root or something like that, we'd end up with some sort of recursive problem because we're effectively calling the function or something. So one way was to create an alias for math. So import math as m or something like that. And now that function of square root, we were calling it in the math function. So all we'd have to do there is change the name of that. And I think we have to get out of our REPL here. So if we run that again, this should work, because now function math is no longer running into the module math because the module math is now referred to as M. So you run that. Oh, there we go. The square root is, as everyone knows, 2.82842727, blah, blah, blah. Like they teach you in school. You gotta memorize that one. But Robert points out that, and James pointed out, why do that? Why not just make a less dumb function name? So instead of doing that, instead of doing an alias, well, let's call this one M instead. Or maybe I'll call this calculate.
Yeah, probably the most important thing is that the final function of main, that's really has no relevance to what the problem is, right? It's only just the import statement, and then the way calculate is defined is where the issue is.
Right, bumping into each other in the namespace. So, boom, same thing. Now, you had some funny ones, Robert. You were saying there was something like undefining the.
Yeah. Yeah, you can there are ways that you can delete symbols, right, from the global namespace. So you can define a function, and then you can, I think the correct term is undefined, although it could be delete. Let me see what I put. Yes, delete. So you're deleting the symbol, or you're deleting the label math, right? And now you can turn around and you can re-import math, and then you, in this case, you just skip creating the bogus function, and you just call math.square root directly.
Okay, so where would we put that? Where do we delete math?
So okay, so you've defined a label called math, right? And then right under that, and I mean back at the fully unindented under that, you would just put the command del for delete.
Okay, so here.
Okay, so here, so your function, get rid of the blank space, so you keep all that together, right? And then before where you have def main, type in del math, right? And it even colorizes it for you to show that's a label. And so now you can import math, and now you're back to where you started, right? But here you're calling math.number, which is still screwy, right? Because when you deleted this, you deleted the symbol math as an override.
Right.
So at this point, what you can do is you can just type in print math.sqrt and just not even fuck with your custom definition, right?
All right,
You
so
just math.sqrt directly.
Gotcha.
Akshay asks, why can't we simply import the math module inside the math function? That's actually a very good question.
That would still work, right? So that makes no sense, because that would be still in the function scope instead of the global scope. So it's not going to get polluted. And when the interpreter is going to run, and it's just going to say this thing as function, which has been called, and that would be still the local scope for that particular thing. So it would still run.
So yeah, so then the real question is, can imports be scoped, right? So that you can limit that import to a particular function.
Before we move on,
I don't know.
The answer is yes, you can. All right. But you run foul of something else. So the issue that we're getting into with this solution is that we're completely changing the code. So I'm not quite sure if that's within Mike Driscoll's rules.
Yeah, I don't think.
Can we go back?
So I have a very curt and concise reply to that.
and one to which most of us will agree. Okay, we back to square one, Woody?
I have a question. When we define a function in line number 3, and what is the use of the definition again, line number 10? Because we can do the same if function instead of main. We can write print the square root of instead of number. If we define something, can we not do that way as well?
Oh, you're saying like instead of calling main and making that
Yes.
yeah,
Print square root of instead of number. Yeah, number is same, and the is math. Yeah, math number. Is it not possible? Or
I
if
think
we, yeah,
there's reasons not to, I think.
if we name the math and say calculate, because the math and the module import math is contradicting one each other, so that way.
Yeah, but now if we're just calling print, we now no longer have a value of number. So, you know, what are we doing? Number is equal to 8 or something, as opposed to just passing in a value of 8. I mean, this I think is still gonna have the same issue. Or wait,
Still gonna fail
yeah, but
in the original code.
No, we have to. Okay.
If you take out line 4, it will fail.
right.
No,
Yeah.
we have to define like a math. After line 12, we have to define like we did a math. Yeah, main 8 instead of that. If we type math and the 8, I think it will work.
Right.
Yeah, so now you're changing the code again by taking out the function at line 3.
Okay.
Yeah.
Yeah.
Say calculate. Say if we put calculate there instead of math.
Okay. So
yeah.
can we go back to can we go back to the beginning, please, Woody?
Yeah.
Well, Control Z is a wonderful thing. Control Z, there we go. We can translate from
Use
one
it all
English
the
to
time.
another. Yeah. So the way that Python, he's getting busy here. The way that Python works is that when it first starts, you're in the global scope. So at line 1, you suddenly enter the symbol math, which is referring to the Python standard library called math.
Correct.
Then at line 3, you redefine, or that is to say, you change the math symbol so that instead of pointing to the library, it's now pointing to the custom function at line 3. Then we go down to line 7 where we define another function. So finally we end up with a second symbol called main. We go down to line 10, main is called. Now what happens now is we leave the global scope and we go into a local scope, which we will call main. All right, it's the second entry on the stack. And at that point in time, we go through looking at the print statement and we try and call the math function. And that works because math is defined in the global scope. It's not defined in main's local scope, but it is defined in the global scope. And so we go to the function that begins at line 3. And therein lies the problem, because when we hit what is currently line 5, we are talking about ourselves. In the math scope, we're talking about ourselves. And it's not going to happen. So yes, one of the solutions was to put in line 4.
Right.
And what that does is, although math is in the global scope, when we start the function at line 3, we start a new local scope, and we can call math there quite independently of the fact that the scope is, if you like, called math. And so that will work in terms of logic. However, it doesn't work in terms of PEP 8, because PEP 8 says, put all your imports at the beginning of your program. Okay. Is there anybody who doesn't understand why this is such a terrible question?
Well, I think it does open up some questions for the 101 crowd. But then also, I'm curious about implementing what James is talking about without going too much longer on this. He says the most indirect way I can think of is with higher order decorator and bytecode transformation / closure and
Oh my
judgment.
goodness. Yeah. The better solution is what Rob said, which is you find the person who coded this function called math at line 3, you take them outside, and perhaps you come back in alone.
There you
and,
go.
and you get rid of that whole function because it's totally unnecessary.
Yeah.
And as suggested before, you modify line 8 and just call square root. You know, why have a function which calls a function and does nothing else? It hasn't added any value.
Or more likely, you come up with all different types of ways to insult the person during code review, right?
Well, that might do something for venting your your situation the way you're thinking, but I'm not so sure that it's a good idea.
Yes,
Perhaps,
not a permanent solution.
yeah.
Actually, a quick question I had was if you have the local import on line 4, you no longer need the line 1, right? I mean, the global import is unnecessary. Is that correct?
Correct,
Right.
because it's not used.
Yeah.
The symbol it's overridden as soon as the interpreter gets to line 3.
Gotcha.
It overwrites is the way we think of it, but it adjusts the pointer that previously pointed to the library to now point to a function.
Yep.
And so you're absolutely right. Get rid of line 1 if you're going to do that. But no, I mean, James's solution at the very beginning was the right one. Keep it where it is. Don't confuse us, because anybody who sees the word math is going to assume we're talking about the Python standard library.
Yeah. Something that can totally happen is you can define a variable called sum, right?
That's a common one, isn't it? Yeah.
What?
That's a common one where people get
That's a
themselves
very
into a
common
tangle.
one. So yeah, so I create a variable called sum, and then later on, and that's obviously not right next to it, I try to call the sum built-in function, and it doesn't work.
Right. James, do you think you could concisely walk me through this obscure technique? Types.function type within the decorator. Decorator for which function? The math function?
So there's a couple of different techniques here,
Yeah.
but the way that line 10 works to actually get whatever this math symbol is,
Right.
is an interesting detail of how the Python compiler works. There's
Uh-huh.
only 3.5 interesting things that the Python compiler does. One of them is scope determination. So when Python creates that math function, it looks at the body of that math function and looks at all the names that are used there, like number and math, and it tries to figure out, okay, where did these names come from? And it knows that number is a local variable, so it generates a bytecode for that saying load fast, this is a local variable. It doesn't know where math came from because it doesn't see it defined anywhere in its local scope or in its closed over scope. So if it can't figure out where the name came from, it's going to assume that the name is global. This is necessary because you can create things that a function refers to after the function is defined. So you can have a function f on line 1 that calls a function g that isn't defined until line 10. So the parser doesn't know where math came from. It's just going to say it's in the global scope somewhere. It's going to be defined somehow, maybe before, maybe after. What you can do through some very hacky techniques historically and through some other techniques, some recent changes were made to how the CPython interpreter works to allow JITs and things like that to work a little bit better, is you can take the bytecode for that math function and you can swap out the load global reference for a load deref reference to turn it into a closure variable instead, and then swap out the function with a function that has the original math symbol in a closure. That way, the code in the body will look identical, but instead of that being a global lookup, it'll now be a closed over lookup. This probably needs a higher order decorator because you'll need to capture what the state of the global scope is prior to the definition of that function. And so I think unless you use some inspect frame tricks, it's going to be kind of tricky to do that. So probably the safest way for a very unsafe technique would be to use a higher order decorator.
Yeah.
Actually, I had another interesting point. And this is kind of interesting about when we talk about global scope, because a lot of people who have C or C++ experience really think about global scope as being the one global scope that exists for the whole program. That's not really how it works in Python. In Python, all modules have their own global scope. It's really module scope. And if you dig into that Python function object that you have, you can actually see that it refers to its particular global scope. Well, if you had two files, they have different global scopes. In Akshay's version, what he is thinking about doing is saying, oh, this function doesn't refer to the global scope in the file that you have here. I'm going to give it another global scope that it can refer to. And in that global scope, the shadowing doesn't exist. Where I think that that is maybe a little bit flawed is we wouldn't know if there's a symbol that's necessary that would be defined later. And so it's likely that you could have a name error here where, you didn't quite, get the right global scope, or there could be a change in names. For example, any sort of monkey patching that occurs, and then you wouldn't be reflective of that because you would have a shadowed scope. However, what you could do, Akshay, is I have to see if this is possible, if you can make the global scope a chain map, so you only override the symbol with the one that you want to keep, and then you have the other global scope. I don't know if you can do that, though. I think your globals has to be a strict dictionary, but that I have to dig and find out.
I think, you can make a chain map, but like you have to store like the global scope as a chain map, so I don't think we would necessarily be updating the globals variable, the output of the globals variable using a chain map. I don't think we can have that because it would be a mapping, and I'm not sure if it's a mutable mapping or anything like that.
I'm not certain. I think you can use dictionary subtypes for your global scope, because that's how prepare works. You can provide anything.
Type.prepare. Okay, then the prepare. Okay.
But I'm not 100% certain that. I have to think a little bit about whether that'll work in this case. Your local scope, however, historically was not really a dictionary. It was flattened into a C array. That's why it's load fast, not load local. But they're actually going to change that, I think, at some point in the near future, and make it an actual proxy dictionary of some sort.
Also, I have when you mentioned about like using function type and the high order function. So basically, are you trying to make sure like the global reference becomes like a non-local for that particular function?
So what you do is you turn that into basically a load deref for a non-local. It's probably the best thing to do. You don't want to make it a load fast. You want to make it something that's outside of its current scope, but that's not a global scope thing. So I think you turn it into a load deref.
Okay, so basically we're just going once. So we're just making one stack.
One step up.
Like we're just popping it up.
Yeah. I think, and the reason you have to use types, or what is it, typing or types.function type, is you can change a function's code object, but you can't change its closure object. The closure object is still read-only. So you'll have to replace the function entirely with something with a new closure.
Amazing. All right. Well, I love it. Most overkill answer to one of these fairly dumb questions, but I mean, to get under the hood like that, thank you guys. That I'm sure we could talk about this quite a bit, maybe even come up with the next Python release. But I think we should get back to the meeting. But thanks, guys. That was awesome.